Okay, so section 9.3 is on the distance formula and circles, which are closely related. We're going to start with the Pythagorean Theorem, which we've seen several times before in this course, because this is closely related to the distance formula. So it says for a right triangle, the square of the length of the hypotenuse equals the squares of the sum of the squares of the lengths of the two legs. So here I've labeled the legs A and B and the hypotenuse C, which is pretty common. And then the formula would be A squared plus B squared equals C squared. Okay, since C is positive, we could write this as C equals square root of A squared plus B squared. Actually, that would be true even if C were 0, but it can't be 0 here, right? Because it's a length that is a length of a side of a triangle. The side of a triangle doesn't have a length of 0. Okay. So I don't need to have the plus or minus square root there because we know it's positive. Okay, so this brings us to the distance formula. We want to know, how do you find the distance between 2 points? Okay, so here I have in the abstract point 1, x1, comma, y1, that's point 1. And then x2, comma, y2 is point 2. I picked specific ones just to make it a little more concrete, and I'm going to do everything with both. So we got 1, comma, 4, and 5, comma, 2. And that just makes it easier for me to explain what's going on with actual concrete numbers. Okay, so that's the distance, or the length of that segment at least, is the distance between the 2 points. Now, we can make a little right triangle like that. Now, if the 2 points are horizontal from each other, you can't make a right triangle, but actually, the Pythagorean theorem still holds as long as you call the length of one of the sides 0, right? The hypotenuse would never be 0, though, still. And same thing if the 2 points were vertical from each other, then one leg would be length 0. And it still works. Okay, so in case somebody thinks about that exception. So what I did is I took the difference. Most people get accustomed to taking the coordinates of point 2 minus the coordinates of point 1. So you see I took the difference in the y coordinates, 2 minus 4, and I got negative 2. Now, the length of that leg is actually the absolute value of that. It's actually 2. But that doesn't really matter because we're going to square it in the formula anyway. It's a squared plus b squared, right? And this side here is actually corresponding to a here. So it's going to be squared. So it doesn't matter if it's positive or negative. But we just have a habit, I guess, of taking the second one minus the first one. And then I did the same thing with this one. The second one minus the first one. 5 minus 1. Right, and you get 4. Okay, and then I'm going to stick it in the formula. Now, of course, in the abstract, that's y2 minus y1 and x2 minus x1. So with my concrete numbers, I get d equals, I changed the c to a d. The D stands for distance, and that's why I labeled this one with a D instead of a C. Because originally we didn't have a triangle, we just had these 2 points and want to know the distance between them, so it's natural to call it D. So I just replaced that with a D there. So this is A squared, right? Oops. And this here is B squared, that thing squared, right? And that'll give me an answer. I don't really care what it is. What I care about is this formula. So this is the distance formula. You need to know this. Just remember, it's really just the Pythagorean theorem. If you had d squared equals a squared plus b squared, right? I just put the square root. I did the square rule and got the square root on the right-hand side. Okay, the y2 minus y1 squared, that's just the length of the side squared of the left side, this side. And the x2 minus x1 is just the length of this side, squared. Right, this squared is this length squared.